Okay, so we're going to look at a question regarding torque. Question 71 says, two wheels of neglectable mass and different radii are bonded together and rotated about a common axis. The smaller flywheel has a radius 30 centimeters. It has a cord pulling with a force of 50 newtons on it. What pulling force needs to be applied on the cord connecting the larger flywheel of radius 50 centimeters such that the combination does not rotate? So I'm just going to label a couple things. I'm going to label this R1. I'm going to label this R2. I'm going to label this F2. I'll just put it over here, I guess. F2, F1. Okay, so we want this nut to move. So if we don't want this to move, then the sum of the torque in our system needs to be equal to 0. If there's no torque, then it'll stay at rest. So let's add up the types of torque we have. And I'll redraw this to make this a little nicer. So for the first one, R1, that's going to be F1 times R1. And we can just take the magnitude. F1. So that's that one. Minus, we can do the same thing here, where this is R2. So that'll be, that's fine, magnitude of force 2, magnitude of R2 needs to equal 0. Or just F1 R1 minus F2 R2 needs to equal 0. With the minus sign being because we'll let right be positive. Well, what are we looking for? We need to know force 2 such that this statement is true. So solving for it, we'll find F1 R1 divided by R2 is equal to the magnitude of force 2 necessary to keep this system stationary. And then when you convert centimeters to meters and plug in, you get 30 newtons. So hopefully that makes a little bit of sense, and you guys are okay with that.